Today's tutorial will be on development economics. We will continue our discussion with regard to the modern theory and concept of economic growth. In our previous tutorial, we have started a discussion with regard to Solow model, and this is a continuation. Now, if you remember, then we started with the fundamental growth equation, and the last equation we came across was Sy is equal to n plus d into k. This is nothing but our fundamental growth equation. Now I'm not gonna go into the details of how we get it, because it was exclusively shown in our previous tutorial or last lecture. Now here we will talk about, or we will start the tutorial with the growth process. That means how we will actually tap growth using this equation, or how we define it. Okay, so let's see. Now from this particular equation, it is evident that planned savings. Now what is the planned savings? Planned saving is nothing but our left hand side, that means our Sy, and if this is greater than the required investment. And what is the required investment? It is given by n plus d into k. And required investment, we require it why? To keep per capita income constant. What will happen is that capital for worker will actually increase. Now this increase in capital for worker, what it will do, it will actually cause an increase in productivity of worker. That means we are connecting links. Okay, productivity of worker. And if this happens, what will be the result? Then the economy. So if this happens, the result will be economy will grow. Just a second. Grow at a higher rate then the steady state, because this is all condition is concerning the steady state. So the steady state equilibrium growth rate. So once this is done, now the question arises that I'll be putting forward to you is whether this higher growth rate, so higher growth rate goes on continuing. That means higher and higher it goes on increasing. So what you can do, you can pause the video a little bit and think about it, because you are actually doing economics from a very long time and you must be able to answer this. Now the answer to this is that this particular process of higher growth rate will not occur endlessly. Now there must be a reason behind it. So can you think about it? The reason behind is, you know it, but it is not coming into the head. And those who guessed it, then it is very good. The reason is diminishing returns to capital, and because of this, what will happen, it will bring it down to the steady state rate of growth. That means this one, though at a higher level of per capita income and capital per worker. Okay, now this is how the growth process actually is taking into place. Now one more thing is that with Solow model there is always graphical representation. Now before any kind of graphical representation, I must give you an idea. The idea is, in order to show the graphical whatever we have done, in order to graphically show this growth process, the growth equation, there should be a little bit of alteration or modernization that you need to do. What is this? This growth equation is conventionally used in intensive form. I know there's a lot of confusion. Don't worry, I'll represent whatever I've written now in a much simpler terms, that is in per capita term. So when you represent it in per capita terms, you can actually graphically portray it. So in order to do this, what you need to do, so you have this equation. So what you will do is that you will divide both sides of this particular equation by a factor L, because it is per worker. Okay, so per capita, so you have SY by L is equal to N plus D K by L. So what is Y by L? Y by L actually represents the income per capita. Similarly, our K by L represents capital per worker, and sometime you may even hear the term capital labor ratio. So if I write in place of Y by L, if I write denoted by small y, and if place of K by L, if I denoted by small k, then I can rewrite this particular equation as so this can be written as S small y equal to N plus D into small k. Now what this equation represents, now if you remember, this is the equation with which we started today's tutorial. Now this equation represents the fundamental growth equation. Okay, now this particular equation also represents fundamental neoclassical growth equation. So what is the difference between these two? Definitely when we have written, if I compare this and this, the two look different, but the name is the same. How it is possible? There is a little addition to this last one, or the second one, is that this is in per capita terms. So this is just the difference between the two, which must be borne in mind. So whenever they ask you in the exam or anything, what is the difference, both are same, both can be used. This is used for the graphical purpose, this is the intensive form, and moreover this is representation of the fundamental neoclassical growth equation, but in the per capita terms. Okay, now in our next tutorial we will actually concentrate on the graphical representation of Solow model. That means we will talk about growth process as well as steady growth rate.